Hello there. Welcome to my talk. This is Token Walks into a Single Page Application. And it's basically a basic introduction to base authentication flow in single page applications. So my name is Nacho Anaya. Technically, Nacho is not my name, but you can call me Nacho. That is my Twitter handle. You can reach me there if you have questions, suggestions, or whatever. And this is me playing hockey. I am a hockey player. I know that it's not what you call hockey, but this is hockey in Argentina. I am from Argentina. I am JavaScript engineer at Block. Block it's a token, it's a blockchain company, basically provides blockchain solutions for other companies. I am also ambassador at Auth0. Auth0 is a single sign-on security company where you can rely the authentication service to a third party. It's very great if you want to deal with authentication, social providers, and user management. It's a great service. And I am the organizer of Buenos Aires, the Vue.js meetup that we have in Buenos Aires. We have a perfect match for the name. And this is a disclaimer about my presentation. Basically, I love to use emojis, so I'm going to use a lot of emojis in this talk. Sometimes it's really hard to make those emojis make sense, so just put a little bit of imagination, right? So the first question that I'm going to answer is why we need tokens or why we need token-based authentication. So let's go to the past and the way that we used to build applications, right? We used to have a big monolithic server where we handle all the application there. We handle the render, we handle the authentication, right? It's like a black box where we have a single point of entry that is the browser, but the browser could not request data if it's not authenticated or if the user does not validate if the server does not validate the user. So we have this flow where the user make a request with the credentials, so the server validates their credentials and probably create a session and then sends to the user the page that the user wants to see. And in the middle of the process, we save a cookie, so we don't need to repeat this process again. And we can validate later through this cookie and the session in the server that the user it's logged in or not. So this used to be the old schema. It's basically a session-based authentication system. And it's totally different from what we are doing now, that we start splitting the monolithic in different kind of applications, right? Especially we have an API. So we split now our whole application in two different applications, the API for the website and the single page application. So basically now we have smaller backends and we have bigger front ends, and those front ends are really dummy without any kind of restriction. Anybody of you can enter or can check the code because it's public, it's everything there. And then we expose a REST API or GraphQL API or whatever we want in the API. So the process is basically the same, right? But we have different considerations now because we don't have more sessions, right? We are doing APIs because we are stateless. So that is one of the things more important. And the other one is that we don't have just one client. We don't have just one website. We have desktop applications, iOS or mobile applications, watch applications, IoT things, even speakers talking to API. So it's a more complex system now where we centralize the backend in an API, and then we have multiple clients trying to consume the data. And the answer of the question of why we need token is because we are going to a stateless ecosystem. So as I said before, we have dummy front ends. We need to make the authentication everything in the backend, but we need to ensure an authentication flow to basically let the user interact with our application and keep the user experience in a good way. So as we don't have more states, we need a way to start talking with our parts, the API, the different clients. And this way is tokens, or are tokens, especially JWT. There are different kind of systems or token-based systems, but we're going to talk about JWT. And JWT is a standard that lets us represent claims in a secure way between two parties, okay? So we can exchange information between two parties, and we can be sure that that information will not be compromised. And how is that? Well, basically, the JWT have someone of you ever worked with JWT before? Okay. So we have three parts. The first one is the header, the second one is the payload, and the third one is the signature. And then we have base 64 around all of these three parts. And those parts are concatenated using a dot. So header.payload, payload.signature. So this is how a token looks like. The red part, it's a header. The purple part, it's the payload. And the cyan part, or light blue, it's the signature. So as I said before, it's JSON web token. So technically, we have JSON. So if we decode this base 64, we are going to get 3 different JSON objects, one for each part. The good thing about JWT is that they are self-contained. Everything is inside the token, so we don't need, once we generate the token, we don't need a kind of interaction with the token generator to validate if the token it's good or not. So inside of the header of the token, we have the algorithm property and the type property. Type will probably be the same always, and the algorithm will depend on what mechanism you decide to use or not to sign the tokens later. So the header basically defines what kind of token are we doing or are we creating, and what kind of algorithm are we using to sign it. Then we have the payload, and it's an important part because it lets us use claims to exchange information between the parties. And we have different kinds of claims in the payload. The first one and the most important are the reserved ones that, for example, ISS, it's issuer, and EXP, that is expiration. So issuer let us know who is the authority creating this token, and expiration, it's obviously a timestamp with the token expiration. Then we have public and private claims. The difference between them is that public are standard and private it's whatever we want. But basically, those claims are the way that we can introduce more data to these tokens. So the idea is to put everything we need in the claims that will let us perform the authorization process later. So if we are handling different kind of permissions, well, probably we need to put the roles and the different permissions inside this part, so the authentication system will later validate if the flow is going okay and if the user has the permissions to access a specific resource. And the last part is the signature. So if we try to do this with JavaScript, the signature is basically a concatenation of the header in base 64 dot the payload in base 64, and then we hash that combination, right, using the algorithm we want, and probably, depending the algorithm, we need a kind of secret or private public key. But basically, everything is there. So this is a good thing about the signature, because the signature provides identity. Basically, it's an encode way of shared data. And that data is public, but this signature let us know that this data will not be changed in the future. Yeah? We can rely on this data here, because if something changed in the future, the signature will not match. So the signature is basically what we can use later to validate if the token is good or was, I don't know, modified by a malicious user or whatever. So this is JWT.io. It's a website where you can get more information. And it's basically a debugger there where you can put your token and decode that and get the JSON information, for each part. And you can see if I generate the token, so if I change something later in the payload, the token will be invalidated. So that's the way, right? You generate the token, and then you will not be able to modify it because it will not be valid anymore. So let's use an analogy using hockey. You like hockey. I like hockey too. So let's use a real-world analogy of how this authentication process works. So imagine that we are going to buy tickets for a hockey game. So we need to buy those tickets probably to the NHL. Just imagine. We can think that our tickets are the token. So in the token or in the ticket, we have the header that could be the NHL, right? The authority issuing the ticket. We have the payload, that is the information that will let us access to our seat, to our row, to our special part of the stadium. And then we have the signature, that it's basically the barcode or an hologram or whatever it can use to verify that the ticket is true or it's a real ticket. It's not a fake one. So if we go with our ticket, the process will be, we go to the NHL, we give the credit card, the NHL give us the ticket, so then we go to the stadium, a security guard will try to scan our ticket with the barcode, and if everything is okay, I will be in, or I will get access to the stadium, okay? So it's the authentication process going well. So you can see here that the stadium and the NHL does not have any interaction, right? It's like one generates the tickets, the other one validates the ticket. So let's imagine that there are no more tickets, so I go to a reseller, and obviously I can't pay in cash, I can pay in card, so I pay in cash, I get my ticket, but this was a bad reseller, so it's a fake ticket, so I'm trying to go to the stadium, I'm trying to validate the ticket, so the security guard scanned the barcode, and it's not a valid ticket, so I am sad because I can't see the game, but the system works because the stadium or the NHL will not let me get in because I don't have a valid ticket. So let's move this to the 2018, right? Let's move this to the web. Imagine that we are in NHL.com. And imagine that NHL.com has a Vue application and a Node.js or whatever kind of API. So the flow here will be that probably to buy a ticket, I have this post endpoint that will be triggered through the single page application. And as I probably need to be logged in to buy a ticket, I need to access or to insert my information, my user data, my credit card, whatever, I will get the 401 error, okay? You can't buy a ticket because you are not authenticated. So probably the SPA will redirect me to the login page. So in this scenario, I will post to the API to get my token, I will send my credentials, and the API will give me back a JWT, will give me back this token. So now I repeat the process. I go now to the same page to buy the ticket. I post the information, my information with my credit card, whatever, but I append to the authorization header in the HTTP request my token. So the same token that I got before by the API, I am using now to validate that I am the user I think I am. So if everything is okay, the API will give me back a 200 status code and the ticket. So this is the happy path. But this is the process that we need to repeat for each authenticated endpoint, right? This is stateless, so we can't keep this session in the server. We need to pass this token for all the private endpoints to make the authentication valid. So let's move to a more complex scenario. So imagine this is something similar as Google. You have your Google account, and you can use your Google account to go to the Google Calendar, to Google Drive, to log in whatever Google service. So imagine that the NHL has the Auth NHL.com. It's an authentication server provider. Then the NHL API. And then we have the Maple Leafs. It's the local team, right? Yeah, OK. So we have the Maple site. And basically, the NHL, it's letting us use the NHL users to buy tickets in the specific team pages. So each page or each team now has its own website, and I can buy the ticket directly in the web of the team. So now what I am doing is basically the same process, but I am splitting the interaction. So first of all, I go to the Auth server, send my credentials, and then I get back my token. Then I go to the API, I send the data and my user information and whatever, the same as did before, but I append the token generated by the other server, okay? There is no interaction between those servers, but the API will be able to validate my token and to get me in. So it's the same process, but we split it in different applications, right? And we have one authorization server and one API, and we can make the interaction with any kind of clients in the middle. So far, so good. Probably this is what we need. Not really. And the problem is that we need to repeat this process. Remember that we need to send the token every time we are going to make a request. So the problem with that is that we need to store the token in some place. So if we store the token, we can repeat this process across the different requests that we want to make, but the question is where we will need to store this token. So can we use the local storage? We don't. Okay, we can't. And the answer is probably most of the authentication posts that you find in Google and the old-fashioned way was to use the local storage to put the token. But it's not really a good idea, okay? Because the storage is not only local storage, session storage, cookies, or whatever mechanism in the client. The problem is that you are susceptible to XS attacks, to CSRF attacks. So basically, you are putting sensitive data there that could be used for malicious users to impersonate you in your website. So you can use it, but it's on your own, okay? It's on your risk, and it's not probably a good practice for security reasons. So the thing is, the only place that we can store the token is in memory. We can have it in our Vuex, in our Vue component, in a kind of centralized store. We can have it in our client code, but we can't have it in the browser. So the problem with that is that anytime we are going to refresh the page, we need to log in again, or anytime we open a new tab, we need to log in again, because we don't have the token in any persistent storage. We have it in memory. So there's a new solution for that it's called silent authentication. It's a kind of complex solution, but it's probably the way that we need to follow from today, right, or from now, to start solving authentication in single-page applications. And it's a little tricky, but the thing that you need to do is when the user log in to the authorization server, you have to create a cookie in the authorization server, HTTP-only cookie. So with that cookie, you can identify a session. Yeah, technically, we will have kind of session in the web server, in the authorization server, sorry. And when you have this cookie created, once you log in, the next time, you don't need to persist this token because you can use an iframe, and this iframe will trigger, it's a hidden iframe, and this iframe will trigger the authentication process. So it's a little tricky, but it works. And basically, the authorization server will be able to verify your token using this cookie. You know, will check using this cookie if the user is logged in or not, if the session is valid, and if everything is okay, you will get a token. So anytime automatically, this server will provide you a new token and will let you avoid storing the token in your client, generating new tokens each time. So anytime you logged in, you get this you create the cookie, everything is stored in the server of the of the authorization server, and then you can use the cookie to generate new tokens anytime. So you can only need to store this token in memory. And if something went wrong in the middle of the process, obviously, you will be redirected to the login page, and you need to access or to enter your credentials again. So it's basically the same flow as we talked before. We have the cookie now in the authorization server, and instead of sending the credentials anytime, because we don't need to, or we are not going to send credentials between applications, we just need to use this iframe to trigger the authentication process, right, and to expect the result from the authorization server. I know it's hard, it's complex, but it's probably the most secure way that we have today to secure single-page applications without compromising the user data. That's probably the most important thing in terms of security. There are some JWT considerations. It's perfect for stateless. You have libraries for most of the languages. I probably would say all the languages. It's a really open standard that you can rely and use in your applications. You have in mind that depending the kind of algorithm that you are using could be more secure or less secure, but it's important to keep the secrets, right? And to keep the private key private. It's probably better to use RS-256 for the algorithm hashing. And it's a good recommendation to keep the token small, because those tokens will travel through all your requests in your application. So try to put as less data as possible there because we don't want to affect the performance. And there are some considerations regarding Vue that are not technically tools to implement the silent authentication workflow, but will let us keep the user experience through the authentication process in the SPA. So probably we can use the Vue router. We have this meta property for the routes, and we can set a specific data there, like if the route is public or not, or if there is a specific permission for access this page. So we can use the meta to add things related to authorization that we need to access specific pages. Then we have the navigation guards in the Vue router. So basically, inside here, we need to resolve authentication, check the user session, check the user if the user has permissions to access that page, if the page is public or not, those kind of things. Then we have HTTP interceptors. I recommend you to use libraries, and maybe Fetch does not have something native, so Axios or Try or some kind of libraries that use HTTP interceptors. Remember that we need to send the token in each request, so we don't want to repeat this process anytime. So using an interceptor or a pattern like this, you will be able to insert in any of the authorization headers of your request, you will be able to insert the token. Then we can use Vuex or any kind of, there's not a really big secret. We can store the token there or any kind of store pattern that we are using for our application. Here are some resources I recommend you to dive in. JWT.io is the probably most basic stuff. You can go there, play with the tokens, and read a little bit more about authentication and JWT. There is a great book about it that you can find the link. I will share this on Twitter later, so you can download all the links. There is a great post comparing the different algorithms of JWT that you can use and why or when you should use each one. And this is a great post. There is not too much documentation yet about silent authentication. It's kind of new pattern, right, that the people of the authentication companies is trying to promote to avoid storing the data in the local storage. It's a really good practice, a really bad practice. So there is a great post there, and you can see how Auth0 is implementing that in their system, and you can probably follow that pattern. And to take away, it's probably, well, SPA is mainly concerned about authorization and not authentications, right? The authentication relies on our backend, and the things that we add in our SPA for authentication are most for UX. We don't want to have the AWS experience where you are, probably you experience that. You are trying to perform an operation. Maybe I want to delete this container. I put delete, I wait 3 seconds, and then I get a message telling that I don't have permissions to do that. So if I don't have permissions to do that, why am I seeing that, okay? So this is the kind of stuff that we need to put the focus in the single page application. The other things are just, these things are UX. The other things are authentication real that should rely in our backends. So JWT are a great choice for this, work for all languages, and it's an open standard, so I really recommend you to do that. And if you don't want to deal with all these problems, probably find something like Auth0, Okta, or some single sign-on provider. Thank you.